Good day everyone, my name is Nguyen. Today I would like to present our full paper entitled Unreined Students or Not, Modes of Freedom in a Project-Based Software Engineering course. So the work is done in the collaboration with Øystein, Nytrø and other co-authors from Norwegian University of Science and Technology. You are looking at the agenda of this presentation. So first of all, we present the motivations for us to conduct this work. After that, there's the two research questions and the research methodology. We also present the cost settings that we conduct this work, and then the results and practical recommendations. Teaching software engineering subjects to students is challenging. We need to provide not only theoretical foundation to students, but also engaging them into practical exercise or experience to train their skills, and then having insights into industrial trends. For example, continuous deployment, DevOps, or lean startups, and digital transformations. Educators often struggle to both ensure lucid research-based lectures and running a smooth but large-scale lab operation. The backbone of our software engineering course is the software development project, where students work in teams and collaborate to produce concrete software artifacts. And hence our task is to fit this real experience with the right level of constraints, theories, tools, and infrastructure within our teaching capacity. When thinking about ways to improve our project-based software engineering course, we recognize there are several dimensions to consider. First, the curriculum itself, the giving lectures, the industrial methods to feed to students, supervisings and supports given to students, and finally, assessment. The level of controls, or how much to control and how much to be free, is the key here. With too much freedom, the students' learning processes quickly degenerate when encountering decision and choice beyond their competence. But with too much controls, it will hinder the innovativeness, shift the competitive spirit among the groups, and may change negatively their behavior. Two research questions are explored in this research. RQ1, what dimensions of students' choice are possible to accommodate in a large project-based software engineering course? And RQ2, what are the strengths and weaknesses associated with such freedom? So the overall research process is shown in the showing picture. So you see that starting from the need for research-based improvement, we conducted and compared different instances of the same course. The two course instances are presented. The first one called approach 1. Every student is an innovator, which is done in 2016, and the approach 2, no students left behind course, is conducted in 2017. We collected pre and post course feedbacks in both instances from students by having them filling in surveys. These surveys provide us not only students' background, their project work, their motivations, and also their students' evaluation of the course. For example, we ask how they think about teaching materials, lectures, exercise, student supervisions, and other project setting dimensions. The surveys also asked about the perceived strengths and weaknesses experienced from the student's perspective. We perform a retrospective comparative analysis to uncover the histories and experience. The unit of analysis here is the course itself, and here we have two instances. We conducted a focus group of four main lecturers from these two course instances, and we discussed our own experience with the course, feedbacks from the teaching assistant teams, comments from other lecturers in the departments, and external guest lecturers. This background provided the perceived strengths and weaknesses of each approach, together with their dimensions of teaching freedom. Particularly, approach 1 emphasized the students' innovative capacities. Inspired by a large number of successful student startups at our campus, we would like to encourage the self-learning process that's driven by joy, curiosity, and discovery. We aim at not only teaching students about fundamental software development activities, but also attempting to introduce novel, inspiring development approaches. Students are also participated in various innovative events, such as interviewing with professional developers, making presentation slides, making posters and videos. Here you can see from the table, in this approach, we have a relative flexibility of all dimensions across the course setting. In approach 2, no student left behind, the main objective was to ensure that a majority of students reach their learning objectives and prevent that entire groups or some individuals in a group would fail to reach a basic learning objective because of unfortunate decisions, group dynamics, or other reasons. Secondary to the idea of not leaving any students unwillingly behind was an ambition to ensure a higher average student competence and experience in software engineering. Some of the dimensions here you can see, for example, they have a fixed project problems. Every team share the same project problems. They have using existing template codes stored in GitLab, assigned group teaching assistants with frequent deliverables, and continuous and systematic assessment under senior supervisions. Okay, so this slide, the next one, will provide a short answers to our research questions, and the longer versions you can find by reading our paper. To answer the research question 1, the possible dimensions to accommodate, we find that all of the dimensions, project setting, cost process, technologies, supervisions, and the final assessment are all possible to allow accommodations, but also they need a certain level of flexibility to cope with the variety of projects students experience and teaching assistant experience. Furthermore, freedom of choice is both inspiring and challenging, but must be balanced with a precise control in order to reach learning objectives and maintain fairness among students. Answering research question 2, we present here a table that summarizes the strengths and weakness of both of the course instance we study. Regarding the approach 1, no student left behind, the strength is a thorough and predictable coverage, a high and average level competence, and effective teaching assistant involvement. However, it might involve too many details that may be relevant to every student. Hard work and maybe sometimes boring for some students, less fun, and negative appreciations of innovations. Approach 2, every student is an innovator, focus on the fun and motivating part, lifelike, realistic learning, and exposure to innovative thinkings in teams. The weak parts, which is uncertain individual learning outcomes, hard to control resource use, and little cross-team communication, and sometimes ineffective usage of teaching assistants. So there are four recommendations we'd like to present here among several others we present in the paper. Firstly, freedom of technology and method choice. We see they reduce the value and validity of teaching assistant aids and assessment. We also experience that freedom of problem selections, increase involvement and time spent. Freedom of team arrangement increase the team competitiveness and potential student lockouts or the whole team value. And the freedom of precise deliverable content and form makes assessment non-transparent and subjective.